looking at position time graphs, um, we're often asked to provide either specific position data or time data. But we can't necessarily do this unless the points in question land on a vertex. So we're going to look at right now how to basically take a line segment, find the equation of a given line segment of y equals mx plus b form, and use this information to gather more information from a graph. So having a look at this graph here that we examined last week in class, we may want to ask the question, what's the object's position at 12.2 seconds? So you can see me marking here on the screen that 12.2 seconds looks to be somewhere shown in red. And if I work that back over from the line itself over to the position axis, it's somewhere between 3 and 4. It looks pretty close to 4 to me, but that's not good enough. I actually want to calculate what is that object's position. So I need to find the y coordinate, or essentially the position coordinate, for the specified time coordinate, so given the x. So if I want to find the slope of this line segment, all right, well, how would you treat this in math class? You would say the change in y divided by the change in x. So I can say y2 minus y1 divided by x2 minus x1. I can convert this into our notation, which would be position 2 subtract position 1 divided by time 2 minus time 1. That change in position is displacement, and displacement divided by change in time is known as velocity. So the slope of a position time graph is equal to the velocity at any given moment along that line segment. So I'm going to look at this line segment and I'm going to look for two good points. The first one I marked off as at 20 seconds and a position of 0, so 20 comma 0 would be the coordinate. The second position that I'm going to work with we'll say occurs at 16 seconds and a position of plus 2. All right, so I have time 1 and then, made a little mistake here, sorry about that. So say time 1, position 1, time 2, position 2, so x1, y1, x2, y2. I'm going to find the slope that links these 2 points. So 0 meters subtract 2 meters divided by 20 seconds minus 16 seconds gives me negative 2 meters divided by 4 seconds, which is negative 1 meter for every 2 seconds. If I want to express this as a decimal, this is negative 0.5 meters per second. So that's the slope at this given time. So that means for every second of time that elapses, the position changes by negative 0.5 meters. Okay, but if I'm going to treat this as a linear equation, I need to find the position at time 12.2. So I don't want to just simply count from any of these points. I'm going to put this in a y equals mx plus b format, and I'm going to solve it. So I can say that y is equal to negative 1/2 x plus b. Okay. In this case, b is the hypothetical intercept that line segment would have if it were drawn all the way back to the y-axis. So I'm saying here-ish, right? Anywhere somewhere up around 10. Now, in order to solve this, I have to take one of the 2 coordinates that I've been using, substitute it into the equation. So I'm going to use the 20 comma 0 point. So I'm going to say 0 equals negative 1/2 times 20 plus b. This will tell me 0 equals negative 10 plus b, and that b must equal positive 10. Now I have the equation that describes the line segment in question, negative 1/2 x plus 10. Okay, so now I want to know where is the object at 12.2 seconds. So I substitute in 12.2. I find out that y is equal to negative 6.1 plus 10. This translates to y equals 3.9. Put this back in my proper position notation. So the final position, or the position, sorry, of the object at 12.2 seconds is plus 3.9 meters.